So this is the formal Lab 1 balloon lab for group 6B. So this first slide has this triangle which we use to represent our model. So the top point C is the middle of the string where the balloons are hanging from. And then A and B are the balloons, and then the 42.5 at the bottom is the distance between the balloons, and 47 centimeters is the distance of the string. And for this we assumed that the distance between the balloons was 42.5 centimeters, but using the video we recorded, it was difficult to see the actual distance on the meter stick. So this is for the forces. So the mass of the balloon was 3.2 grams, so it's 0.314 newtons in the y direction down, which means it was also 0.314 newtons going up. And then using the angle that we had before, we can find into the 63.1 degree angle, then solve for the x direction of force. So the x direction of tension was 0.159 newtons. So that means that the electric force between the balloons is also 0.15 newtons in the opposite direction. For our experiment, we needed to find the mass of the balloons, which was 3.2 grams, the distance between them, which is 42.5 centimeters, the length of the string, which was 94 centimeters, and the angle between the balloons, which we figured out using the triangle with the length of the string and the distance between them. For the calculations, we had to find the charge of each balloon. So we have the force, 0.159 newtons, equals K, which is 8.99 times 10 to the negative 12th, 2Q for the two balloons, over the distance squared, which is 0.425 meters squared. And then you solve for 2Q, which we got 3.126 times 10 to the negative 12th, then you divide that by 2 to find each charge of the balloon. So each one was 1.598 times 10 to the negative 12th.
After determining the charge of each balloon to be 1.598 times 10 to the negative 12th coulombs, we were tasked in finding the number of electrons for each balloon, which we did by dividing the charge of each balloon by the charge of an individual electron, which would give us the number of electrons, which we found to be 9.9 million. And then our model that we used to do this was fairly accurate. Our calculations were as accurate as they could have been, but our measurements were based off of the video, so they can only be so precise. And to make this experiment as accurate as it could have been from measuring from a video, we used a meter stick underneath the two balloons in the video to better gauge the distance between them. And we also used a protractor at the top of the string to determine the angle between them. And doing this, you can only be so precise from the video. It was difficult to do this, so there was some inaccuracy there, and that would impact the calculations. And then our assumptions were the angles between the string and both strings and the horizontal were equal on both sides, and the charges of both balloons were equal.